Greetings, welcome to my YouTube channel on networking. I want to share my networking knowledge through video presentation as a part of my learning. In this series, we're going to cover important topics in networking. The topic covered will be helping to develop networking skills and assist you in preparing for networking exams. We will also perform labs in this series to understand the networking concept. In this session, we'll discuss about network models, devices, and addressing. So let's just start with networking models. Networking models provide a conceptual framework for understanding how different elements of a computer network communicate with each other. Two of the most widely used networking models are the OSI model and the TCP/IP model. The OSI model are classified into seven layers. Um, Physical layer concerned with the physical connection between devices. It defines hardware specifications such as cables, connectors, and transmission rates. Data link layer deals with the reliable transmission of data frames between nodes on a network segment, provides error detection and correction. The third is the network layer, manages the routing of data packets between devices on different networks, responsible for logical addressing and packet forwarding. Fourth is the transport layer, ensures end-to-end communication between devices, um, manages flow control, error corrections, and retransmission of lost or corrupted data. The fifth is the session layer, manages, and terminates sessions or connections between applications, synchronizes data exchange between applications. And the sixth, we have the presentation layer, transit data between the application layer and the lower layers, handles data compression, encryption, and formatting. Then for the seventh, we have the physical layer, which provides network services directly to end users or applications, includes protocols for file transfers, email, and other high-level functionalities. The next model is the TCP/IP model. The TCP/IP model is a more practical and widely used networking model, particularly in the context of the Internet. It consists of four layers. Link layer, equivalent to the combination of the OSI models, physical and data link layers, deals with the physical connections and access to the network medium. The Internet layer, similar to the OSI network layer, responsible for IP addressing, packet routing, and forwarding. The third is the transport layer, similar to the OSI transport layer, manages end-to-end communication, error recovery, and the flow control. Application layer combines functionalities of the OSI presentation and application layers, provides network services directly to end users or applications. Next, we'll explore the network devices that are operating at each layer. Networking devices are physical or virtual components that facilitate the communication and data transfer within a computer network. These devices play various roles in connecting and managing data traffic within a network. Here are some of the most common networking devices. Firewalls operate on layer 4s and higher and are used to protect network from outside threats. Routers operate at layer 3, the IP layer, and are used to connect network. The main purpose of it are to connect to the internet and route traffic between offices located in various places. Switches operates at layer 2, data link layer, and computers in offices sharing a single building are connected by switches as part of a local area network, also known as a LAN. So let us move on to networking addressing. Networking addressing is a critical aspect of computer networking that involves assigning unique identifiers to devices within the network, allowing them to communicate with each other. There are two main types of networking addressing, IP addressing and MAC addressing. MAC address, which is basically the media access control address, is a unique identifier assigned to the network interface card of device for communication on a physical network. It is a 48 bit, which is basically 6 bytes expressed in hexadecimal. address typically expressed as six pairs of characters separated by colons. In the example shown, the first three bytes represent the vendor, OUI, organization unique identifier, and the last three bytes represent the device NIC address manufactured by the vendor. MAC addresses are used at the data link layer 2 of the OSI model. IP address, the Internet Protocol address, is a numerical label assigned to each device connected to a computer network that uses the Internet Protocol for communication. There are two versions of IP address in use, IPv4, which is a 32-bit, and IPv6, which is a 128-bit. IPv4 addresses are expressed as four sets of decimal numbers separated by dots. Example 192.168.1.1. IPv6 addresses are expressed as eight groups of hexadecimal numbers separated by columns. Anyways, thank you for watching. If you find this content useful, like and share it, and we will continue with more videos on the networking topics.